The Earth is an interesting planet. The Earth is made up of plates. Plates are large pieces of the Earth's crust. This is a picture of a cliff, a flowing river, and the sun beaming. Clouds have formed over the river. It is starting to rain. This is called weathering. This rain is going to break down rocks and other materials in the river. Wind is also a contributing factor in weathering. Because of the constant pressure of the rain, weak pieces of rock are broken down and fall off the cliff. The piece of rock that has fallen off the cliff is an igneous rock. An igneous rock is formed by the cooling of magma. Erosion is the movement of broken down rock. This rock is carried along with the river current. The rock continues to move. Because of the constant pressure of the weathering, the rock is broken down again. The broken down rock sinks to the bottom of the river. Here we have the Earth's plates that are in constant motion. You are looking at a denser plate subducting under a lighter one. The center of the Earth is very hot. The heat from the core helps move the plates. The heat from the core and the sediments from the subducted plate come together to form sedimentary rock. The heat and pressure from the core turns the sedimentary rock into metamorphic rock. The heat from the core melts the metamorphic rock and turns it into magma. The magma cools beneath the Earth's surface and turns into intrusive igneous rock. A volcano is another way rock changes its form. The volcano is starting to erupt. The magma from beneath the Earth's surface is erupting from the volcano. Magma that is above the Earth's surface is called lava. The lava is flowing down the side of the volcano. As this lava is flowing, it is also cooling. This is one way extrusive igneous rock is formed. This cycle is constantly repeating. A glacier is another natural feature that exposes the rock from beneath the Earth's surface. As the glacier moves, it removes layers from the Earth's surface. The glacier removed layers expose deeper layers of rock beneath the Earth's surface.
This is the rock cycle.
Rock cycle experiment. How steep can a sand dune be? Deposition. Our hypothesis. We think the jar with the water will have no slope because the water takes the shape of its container. We think the second container, the second jar, with the dry sand in it, will have the highest slope because the sand is not heavy and can move high along the sides of the jar. We think the second jar with the damp sand will have a lower slope because of the water mixed in with the sand. It makes it heavier and more condensed. It will not rise as high as the dry sand will. What we need for this experiment are 3 glass jars, 1, 2, 3, a washable marker, color of your choice, and a protractor. Fill 2 of the jars halfway with sand. This jar is half full of sand. And fill the third jar halfway with water. Each jar with sand, turn it sideways and even out the sand so that the surface is equal. Second one, even out the surface of the sand. And the water will even out when you turn it on its side by itself. Draw a line where the surface of the sand is on the side of the jar and on the bottom of the jar. And do that for both jars with sand. And do the same thing with the water. Draw a line on the side and on the bottom. We are going to gently roll the jar to see the slope of the water. As you can tell, the slope of the water never changes because water keeps the shape of its container. So the slope of the water is 0. Now we're going to take a jar with dry sand and measure. We're going to gently roll the jar till the sand reaches its highest slope, and then we're going to measure the slope. So as you see, I am rolling it very gently to see where the highest slope. So my sand has reached its highest slope, and I'm going to measure it from the blue line that I drew on the bottom of the jar. I have measured 70 degrees, so the slope of the dry sand is 70 degrees. Now we have the second jar, and if your line in the center at the surface of the sand is gone, just redraw it in. Now, for the second jar, add a little bit of water to your sand and shake your container. I've added the water already and I've shaken it. So we're going to do the same thing that we did for the first jar and the jar with the water. We're going to gently roll the jar until we see the highest slope of the sand, and then we're going to measure it. So we'll just roll it a little bit, and I think we've got the highest slope. So now you measure the highest slope, and I'm measuring about 40 degrees. So the damp sand, the highest slope of the sand is 40 degrees. In conclusion, our hypothesis was correct. The water had no slope. The first jar with the dry sand had the highest slope, and the second jar with the damp sand had the second lowest slope. In physical geography, a dune is a hill of sand that is either built by water flow or wind. Sand dune shape is determined by how much sand and what type of sand is available, how much space it is being created in, and what direction the winds are blowing.
Fourth side break. What's 9 plus 10? I ain't got no type. Nah.
Where's the cap?
I got no idea. No.
Where's the cap?
Teen Mom 2.
Now for the second jar, we've made the sand moist, we've added some water to it, and now we're going to do the same thing we did for the first jar and the water jar. I'm going to re-add the line just in case you can't see it anymore at the surface of the sand on the side and the back of the jar. And then we're going to rotate the jar till the sand is at its highest slope, and then we're going to measure it. Now, with the second jar, we're going to take the sand. We made it moist, damp, we added water to it, and just in case your lines are gone, you can reapply your lines to the surface of the sand in the jar and to the bottom. Then take your sand and rotate it the same way we did before until you see the slope. Slope of the sand.